Now, when continuing with the inverse Z transform, the various methods that we have discussed so far, the direct division method or the partial fraction expansion method or the inversion integral method. This is the third method. The fourth method, that is difference equation method, out of which by basing on a simple equation or a solution, difference equation that we have I have already written here, x of k plus 2 plus 3x of k plus 1 plus 2x of k is equal to 0. We are bound to find out what is x of k from this, right, using inverse Z transform method as well as inverse Z transform method, which is the difference equation method. Wherever you are having this x of k plus 2 or x of k plus 1, all these are time advanced functions which we have discussed in our earlier classes regarding time shifting theorem. In the shifting theorem, right, therefore we will try to recap what is a time shifting theorem here in this one, so that we can easily apply. We know that Z transform of x of k is equal to x of z. Now what is this Z transform of x of k plus 1? Z transform x of k plus 1 is nothing but z into x of z minus x of 0, which is nothing but z x of z minus z x of 0. Similarly, Z transform of x of k plus 2, you can write it as z square x of z minus z square x of 0 minus z x of 1. Now the values of x of 0 and x of 1 are given to us. Therefore, x of k plus 2, Z transform x of k plus 2, x of k plus 1 and x of k, we can just simply substitute these values there, and eventually you can find out from getting the Z transform, take these things, instead of in terms of x of z, you will get in terms of x of z, you will get in terms of powers of z. Therefore, first thing, we will replace these things here, x of k plus 2, therefore, now x of 0 is equal to 0, x of 0 is equal to 0, therefore, we have this as, and x of 1 is equal to 1, therefore, we have this as z square x of z minus z, z square x of z minus z, and this one, you will be having it as z x of z, because x of 0 is 0, and z x of k is equal to x of z. Now let me consider this equation, x of k plus 2, the Z transform of x of k plus 2, the left hand side, plus 3 x of k plus 1 plus 2 x of k. When I am applying Z transform to this, what I am going to get is z square, Z transform x of k plus 2, you have z square x of z minus z. Then Z transform x of k plus 1, that is 3 times of x of k plus 1. Z transforms of x of k plus 1 is z x of z plus 2 times of x of z is equal to 0. Is equal to 0. Therefore, I consider all x of z terms into one place, and I will obtain z square. When I consider x of z common, I will have z square plus 3z plus 3z plus 2 and minus z. If I take it to the right hand side, I have this. Therefore, x of z is equal to z by z square plus 3z plus 2. So from this equation, you are going to find out what is x of z. That is, I have applied Z transforms to this difference equation which is given to us, with considering the initial values, x of 0 is equal to 0 and x of 1 is equal to 1, and then I have obtained x of z is equal to z by z square plus 3z plus 2. Right. So now I will have to, my intention here is to find x of k. To find x of k from x of z, it means that we are going to apply inverse z transforms. To obtain x of k from x of z, you will have to apply inverse z transform. When we are applying inverse z transform, it is always important for us to find out the poles and zeros of x of z. So what is x of z for us here? Z by z square plus 3z plus 2, I can write it as z plus 1 into z plus 2. Now, when we have already discussed partial fraction expansion method, I can go for x of z by z based on the partial fraction expansion method. I will bring z to this point and I will write z plus 1 plus into z plus 2, where I can say that it is a by z plus 1 plus b by z plus 2. Now, it is eventually necessary for us to find a and b. Now, what is the value of a? Eventually, I will make it a little faster. With z is equal to minus 1, I can obtain, and I can say it is 1 by 1. I have 1, and b, z is equal to minus 2 plus 1, it is minus 1. So b is minus 1, a is minus 1. Therefore, I have x of z by z is equal to 1 by z plus 1 minus 1 by z plus 2. Now I have tried to obtain a and b so fast because it is already explained to us, it is already understood by us that we are going to find how to find a and b from those two equations. Therefore, what we have obtained is x of z by z is equal to 1 by z plus 1 minus 1 by z plus 2. Now if I cross multiply and take z to the other side, I have z by z plus 1 minus z by z plus 2. Now here is the point where we will have to apply inverse z transforms. Now this one, if I consider z, divide throughout both numerator and denominator with z, I have 1 by 1 plus z inverse minus 1 by 1 plus 2z inverse. That is x of z. Now in the previous case, when we were studying z transforms, what is the z transform of a power k? Z transform of a power k is z by z minus a. Z by z minus a. Now if a is equal to 1, a is equal to minus 1, you are having minus 1 power k. So a power k indicates minus 1 power k in our case. And if a is equal to 2, a is equal to minus 1. If a is equal to minus 2, a power k is equal to minus 2 power k. Therefore, by applying inverse z transform, it's an analogy. We have x of k is equal to minus 1 power k minus 2 power k for all k is from 0, 1, 2 and so on. So you are getting the output or the solution of x of z or the difference equation. You are using the difference equation, finding out x of z, and from x of z you are applying inverse z transform and finding out x of k again. So this is the result for x of k for this differential equation which you are given based on the initial conditions x of 0 is equal to 0 and x of 1 is equal to 1. If the initial conditions are changed, you will get a different result, and so the result is depending upon the initial conditions.